So today what we're going to do is we're going to be looking at how to find and verify mathematically that we are taking the shortest possible path. So we have our network. What we're going to do is we're going to start somewhere and go to the end, and that end can vary. They'll tell you different scenarios, but we're going to work out the shortest possible path for getting from point A to point B. Okay? Now we're going to do that using tree diagrams. I know you remember these and love them. So it's a good review also for your probability because the tree diagrams that you're going to use here are very similar, right? So first, you're going to have a starting point. They're always going to tell you at which point you want to start. Then, you're going to have a branch for each edge. And remember, the edges are simply those lines that go from one node to the next. Okay? And then you're just going to continue to branch until the destination. Right? So just continue to branch all the way to the end of your destination. Now, that doesn't necessarily always mean to the end. There may be places where you're just going so far, and that's your stopping point. Okay? And finally, you're going to weight the roots. What that means is simply add the times, miles, etc. Whatever units you're working with as you're going along. So if it takes 3 hours to take this trail and 4 hours to take that trail, that's the weight of the route. So you're going to add them all together, following each branch, and get a weight at the end of each one. And the shortest path is simply the smallest one. So the smallest weight is the shortest path. So it's very straightforward. And the only math you're going to have to do is some simple addition. Okay? But notice that there may be more than one. So always be prepared that there may be one or more shortest paths. But they have to be exactly equal. Okay? Otherwise, you just pick the shortest one. So we're just going to go to the book and look at a couple of these. It's pretty straightforward. Let me give you just a moment if you want just a minute to finish writing all of these things down. Okay? So when you're finding your best path, your shortest path, make sure you consider any other factors to make the best option. Again, that's how you get your merit. You can do it by reasoning, but you need to be able to justify your answer with numbers. So that's not a good idea. So so I would recommend that you just use the tree diagram, and that way you can find the shortest route. So we're going to look at this one. Find the shortest route from start A to the finish H. The distance are in meters. Make sure you're using units as you go. All right. So just looking at the diagram, what we're going to do, start is A. So we're going to give us a starting point of A in our tree diagram. And from A, we have an edge that goes to B. We have an edge that goes to E. And we have an edge that goes to F. Now, F looks very unlikely because it's so long, but do every branch because there might be a shortcut from F to H. You never know. Okay? Then, after that first set of branching, and you need to weight them, put the numbers on so you can add them up later. Then you're just going to go to the second set of branching. Now we're trying to get here. So from B, I can either go to E or I can go to C. E has a distance of 9. C has a distance of 21. From E, I can go to G or I can go to C. So you see I'm just labeling every possibility. From E to G is 10. from E to C is 13. From F, now there's no point in me going up to G because here's H, that's where I want to finish, so I can just go straight on to H. And that's 18, right? Now, that path is finished, but the others are not. From here, from this path for G, I need to continue, but there's no point in continuing that one because you see it's just going to wind you around and take more time and more distance to go. So if at any point you see that some point like this E to C is not going to be the shortest path, just ignore it, okay? So from here, from C, though, I can go straight to H. So this C, I can go straight to H, and that gives me a path of 8 meters, right? I'm not worried about D at all because it's not even on the route to get to H. So you could continue these pathways here and here, or here and here, but you know they're not going to be the shortest ones, so we're not the least bit interested right now. Again, we're only interested in the shortest possible path. So the E one didn't work. This C one did not work. So all I really need, oh, and this G one from here, there's no point in pursuing that one either. So the only two that I really need to look at are here and here. So we have 8 and 21. So 29 plus that makes 37. And here we have 20 and 18, so that's 38. So our shortest path is there. And to answer the question, you need to label the pathway and give its weight. Okay, so much like the tree diagrams that we made in probability, except this time you're going to be working with the distances. Now, let's make sure that that is indeed the shortest path. There they go. They started it off, weighting those, going along, branching off, and when you finish one, you got the end, and found them all. Oh, wait a minute. There was one I missed. Okay, A to E to C to H. All right. Well, you better be more careful than I am, because A to E to C to H was indeed the shortest path. I remember that being on there. There you go. So A to E to C. I missed from going from E to C and then to H down there. I went down from E to G, but I didn't go from E to C, sorry, and to H. So it doesn't look like the shortest path. This looks like that would be the fastest, easiest way to get there, but because this one has more turns in it, but that turns out to be the shortest path. Don't miss branches. Okay? So again, look at how they labeled it. You label the path. The weighted value of the shortest route is simply 32 meters. Okay? Let's do another one, see if I can get it right. Highlight the shortest paths on the diagram and give their weighted values. The diagonal distance between the adjacent dots is 1 unit. It makes it nice because that means every one of them is a distance of 1, so they're easy to add. Okay? Now, they don't have any values on them, so you just know that you have a starting point and a finish point. So what you can do is you could label them, and traditionally these are labeled with capital letters. Now we don't put numbers on them because it might be confusing to use numbers as well as the weights having numbers as well. So just label them with capital letters. And the pattern you use doesn't make the slightest bit of difference. Okay? Don't even need to use these because it's not going to end up being used over there. Okay? Then you can just follow the pathways. So again, our start here is at A. So we'll put a starting point at A. From A, I can either go to B or I can go to D. And you could put the values in there, but it really doesn't matter because in this case they're all ones, but we'll make it easier, a little easier later. Now I'm trying to get to my finish. So the most direct route would be to go from D to E, and then E to F. And that gives me 3 units. Or I go A, B, from B to E, and E to F, which is also gives me a path of 3 units. Because these are uniform, so uniform, then we ended up with 2 that end up with the same shortest path length. Okay? So it's pretty straightforward. Just going to follow the pathways. Make sure that you're making those tree diagrams, and don't do as I did and skip some. Finish all of your diagrams. Again, this is a place where those colored pens might really come in handy. If you change colors as you go, then you'll know that you're getting every pathway. Okay? All right. There's really no trick to this. It just takes some practice, and you just have to stay focused and organized, because when you look at some of these networks, they're a little crazy. Yeah? So again, those colored pens might really help. Also, pay close attention, because they'll use the same network and tell you the shortest path from V to M, and then the shortest path from something else to something else, etc. So make sure that you know. So like this one, Greymouth to Murchison and Greymouth to Picton. So make sure that you're following, you know exactly what it is that they're looking for. Okay. All right. Look pretty easy? It is. And then next time we meet, we're going to talk about finding a path that would allow us to visit every point of interest on the way. And then we're going to do our last one. And all of these 2 are the merit questions. So the achieved is just drawing a network and labeling the nodes and finding if they're even and odd. And traversability is our next thing. That's another merit thing. And then after that, there's only one excellence thing that on this paper. So pretty darn easy to be able to get through this one. So we should be able to get through it pretty quickly if you'll do some work on practicing these. Then we'll do a practice paper together and maybe assign one for you. And there's nothing on Education Perfect, but there's some things in the book. Everybody able to access the book on your OneNote? Yes, if you didn't have your book, good. Glad to know. All right. We'd be sad if that's all we have to do and y'all have to go to work now. Okay. Yay. All right. So give those a shot. You don't have, as you saw, there's about a dozen of those things. You don't have to do all of them, but don't skip. Start with the easiest ones and don't skip the hardest ones. All right. Okay. Boy, y'all are having fun. I don't know what y'all are laughing at. I wish I knew sometimes, and other times I'm really glad I don't. All right? Okay. Well, then, that's all I have for you. So go for it. Find the shortest path. Do some of them. Okay?
Thanks.
Thanks so much. I'll see y'all later. Enjoy your afternoon. Go outside. Play.
Thank you.
Bye. Thanks.